Picture this. You step into a machine, flip a switch, and vanish. Seconds later, you reappear, but it's 50 years in the past, or 50 years in the future. That's what every movie has trained you to expect. Back to the Future, Interstellar, Avengers Endgame. And here's the twist nobody tells you. Some of that is closer to real physics than you'd think, and some of it is complete fantasy. So let's actually answer the question. Can humans build time travel? And if we can, what would it really look like? First, forget the machine with blinking lights and a big red lever. Real time travel doesn't need a machine like that at all, because in a way, it's already happening, all around you, right now, whether you notice it or not. Here's the simplest way to understand it. Time is not the same everywhere. It's not one giant clock ticking at the same speed for everyone in the universe. That idea alone breaks how most people picture time, because it feels like time should be the one thing that's constant, no matter where you are. It isn't. Time speeds up and slows down depending on two things: how fast you're moving and how strong the gravity around you is. That's the whole secret. Move faster, and time slows down for you compared to someone standing still. Sit in stronger gravity, and time slows down for you too. It sounds impossible, but it's been tested, measured, and proven over and over again using real equipment and real results. In 1971, scientists put super precise clocks on airplanes and flew them around the world, while identical clocks stayed on the ground. When the planes landed, the clocks didn't match anymore. The ones that flew were behind, just by a tiny fraction of a second, but exactly the amount predicted decades earlier by Einstein. Nobody had to speculate or guess. They ran the experiment, and the universe answered back exactly the way the math said it would. Moving fast enough, even in something as ordinary as an airplane, quietly pushes you forward in time compared to someone standing still on the ground below you. Now take that idea and scale it up. Astronauts on the International Space Station fly around Earth at over 17,000 miles per hour. Because of that speed, astronaut Scott Kelly, who spent nearly a year up there, came home about 5 milliseconds younger than his identical twin brother, who stayed on Earth the whole time. 5 milliseconds is basically nothing you'd ever notice in daily life, but it proves the principle works on a real human body, not just a lab clock. And principles that hold true in small doses tend to hold true in big doses too, which is exactly where things get interesting. Imagine a spaceship that could fly not at 17,000 miles per hour, but close to the speed of light, the fastest anything in the universe is allowed to travel. If astronauts spent 5 years on that ship, flying out and back, decades or even centuries could pass back on Earth, while only 5 years passed for them. They'd return home barely aged, stepping off the ship into a world that had moved on without them. New cities, new technology, maybe even generations of a family they'd never meet. That's essentially the plot of Interstellar. And here's the part that surprises people. That movie wasn't exaggerating for effect. A real physicist actually helped design the black hole in that film using real equations, not just special effects guesswork. Flying near light speed really would let you leap forward into the future. Forward time travel isn't science fiction. It's a physics fact we've already confirmed with real instruments. We just haven't built anything fast enough yet to make the jump dramatic instead of measured in milliseconds. So forward is possible, at least in theory, if we ever build engines fast enough. But let's be honest, that's not the time travel people actually dream about. Everyone really wants to know about the other direction, going backward, meeting your younger parents, stopping a mistake before it happens, warning your past self about something. That's the Back to the Future dream, the one where you climb into a car, hit 88 miles per hour, and end up in a different decade. So can we do that? This is where gravity comes back into the picture, and where the honest answer gets a lot murkier. Gravity doesn't just pull you downward. It also slows down time. The stronger the gravity around you, the slower time moves for you compared to someone farther away from that gravity. A clock sitting at the bottom of a mountain ticks very slightly slower than a clock sitting at the top of that same mountain because gravity is stronger down at the base. This isn't just a fun fact to impress people at a party. It's something engineers deal with every single day. GPS satellites have to constantly adjust their onboard clocks to account for the fact that time moves differently up in orbit than it does down here on the ground. Skip that correction even for one day, and your phone's map would drift off by several miles. Now push gravity to its most extreme setting in the entire universe, a black hole. Near a black hole, gravity is so overwhelming that time nearly grinds to a halt for anything close to it. compared to someone watching safely from a distance. Some physicists have proposed that under the right conditions, conditions that are extremely unlikely to occur naturally, warped space near objects like black holes, or theoretical shortcuts called wormholes, could connect two different points in time, not just two different points in space. On paper, that opens a door to looping back into the past. But on paper is doing a lot of heavy lifting in that sentence, because turning that math into something real runs headfirst into walls that no engineer currently knows how to break through. To hold a wormhole open long enough for a person to walk through it, you'd need a type of matter that pushes instead of pulls, something scientists call negative energy matter. This isn't pure fantasy. Tiny, fleeting traces of it have actually been detected in real lab experiments. The problem is scale. You'd need an amount so enormous, so far beyond anything we can currently produce, that it's like knowing a single drop of water exists somewhere and being asked to fill an entire ocean with it. And getting close to a black hole to use its extreme gravity isn't a shortcut either. The gravitational pull would stretch your body like taffy long before you got anywhere near the edge, a process physicists genuinely call spaghettification, because there's no way to describe it that doesn't sound a little absurd, and no way to survive it either. Then there's a problem that has nothing to do with engineering at all, and everything to do with logic. This is the one that every time travel movie eventually crashes into, usually by just quietly changing the subject. If you went back and changed something, stopped your parents from ever meeting, for example, would you simply cease to exist? Would the version of you doing the changing still be there to see the result? This is called the grandfather paradox, and it's the reason so many time travel movies avoid explaining their own rules too closely, because the rules tend to fall apart under real scrutiny. Physicists have two serious answers to this paradox, and neither has been proven, but both are taken seriously by real researchers. One idea, proposed by Stephen Hawking, is that the universe actively protects itself from paradoxes, that nature simply won't allow contradictions to form, the same way it won't let you create energy out of absolutely nothing. Under this idea, something would always stop you, some small, unavoidable obstacle, before a true paradox could ever happen. The other idea borrows from quantum physics. Maybe going back in time doesn't rewrite your original past at all. Maybe the act of going back splits off a brand new timeline, a parallel version of events running alongside the original, while the timeline you came from stays exactly as it always was. Neither one is confirmed by evidence. Both remain live possibilities precisely because the equations don't rule either of them out. So here's the real, honest answer, without the Hollywood polish. Forward time travel, real, tested, already proven with airplanes and astronauts, and something we could eventually make genuinely dramatic if we ever build ships fast enough to approach the speed of light. That part of the science fiction dream is achievable in principle, just not anytime soon, and not with anything close to today's rockets, which are nowhere near fast enough to matter. Backward time travel. Not flatly impossible, but blocked by walls that are currently unbreakable. Types of matter we can't produce in any usable quantity, gravity extremes that would destroy anything that got near them, and a logical paradox we still don't fully understand how nature avoids. If it's ever solved, it won't be with a car hitting 88 miles per hour, or a phone booth, or a machine with a big glowing dial you turn to a specific year. It'll be with physics we haven't discovered yet, built by people who don't exist yet, using tools we can't currently imagine. Here's the part worth remembering after this video ends. You don't need a time machine to already be living inside a universe where time bends. Every flight you've ever taken nudged you forward in time by a sliver of a second, whether you felt it or not. Every GPS signal that gets you home safely is quietly correcting, right now, for time running at a different speed 40 miles above your head. Time travel, in the way Einstein actually discovered it, isn't a fantasy invention waiting to be built in some future lab decades from now. It's a real property of the universe you're already standing inside, today, in this exact moment. You're just moving through it at ordinary human speed, on the slow setting, same as everyone else, waiting to see how much faster we can go.